All right, so I've just put a couple of announcements here in the shared screen. So again, this is just a midterm review session. So I don't have a prepared lecture, but is meant to sort of help you with any standing questions you have to try to alleviate some anxiety moving into the midterm. The midterm is on Thursday, so in 2 days, and it'll be all on Canvas. It's all online. So basically what happens is Thursday at midnight, so Wednesday night, Thursday at midnight, a 24-hour period starts where the midterm becomes available to you. And then at that point, you can start the midterm whenever you like. There will not be lecture that day. So if you'd like, you can start it at noon, Arizona time. But you can start whenever you like. It doesn't have to be during lecture, but there will not be a lecture that day. And then you get 90 minutes. So that's supposed to be 75 minutes plus like 15 minutes of technical, for time for any technical issues that come up. And you have to complete it during that 90-minute window. You have to use Respondus lockdown browser with Monitor. So there is that compliance check assignment that a good chunk of students have already completed. You need to complete that in order for that midterm module to be available there on Canvas. And that midterm module also has things like the past midterm and the solution set. So there's a lot of good studying materials there. So I definitely recommend that you use that module, or that you do the compliance check as quickly as possible or as soon as possible. Then you'll have access to the midterm on that Thursday. And then from there, and I think some of my share might have stopped. And then from there, you can, where did my Zoom go? Sorry about that. So then after you finish that midterm on Thursday, you will get your score and you'll be able to see the midterm solution set and how well you did on a per question basis on Friday. And then you'll have a week to decide if you would like to take the midterm retake, which will be next week, next Thursday, October 29th. And that retake, will be a different test, but it'll be of similar length. So when I make them, I make one question on one, and I try to make a question that'll take you a similar amount of time going over a similar amount of content right next to it. So it'll be kind of a mirror midterm, and you are then free to take that midterm if you would like. You don't have to. Likewise, you can just take that midterm if you don't want to take the midterm this week. They will be different tests though. So a solution set goes available for this midterm, and a totally different midterm next week comes up. But it, again, is supposed to be similar length, similar content, similar difficulty. And I will take the best score from those two tests. So again, hopefully that alleviates a little bit of anxiety. So that's the setup of things. So with that, I want to say, are there any questions about the setup of the midterm, or just any content questions, any problems you'd like us to work through? I guess let me also mention, because I've added this, is there was so sometimes students like kind of a study guide. So what I've done is in the modules on Canvas, at the top of every module, I have made available these learning outcomes that specify what I think you should know coming out of each unit. And those are the kind of the things that I'm using to decide what to test on. So, and I guess just in case, sometimes, I mean, I think most students are using Canvas fine, but occasionally I've been getting questions from students that make me worry that maybe not everybody knows where to find everything on Canvas. And so I am going to share my Canvas screen here. So this is the instructor view of the module. So it looks a little different than yours, but I just want to point out that if you're looking for the recorded lectures in the course information module, so in Canvas, you go to Canvas, you see a home page that looks like this. And then down here, if you're looking for the recorded lectures, you can find them here, for example. So that's all of our, that's the current lecture that we have right now will show up there. But also if you go under modules, you find a bunch of good info. So under course information down here, I've also got a link to those captured recordings. They're also down here in the classroom recordings module. So that's how you find all of those recordings. But then there's all of our units. So some of you may have been accessing your assignments just through the to-do list. but you can also get them and all their solution sets under these modules. So the Unit A module has got Unit A learning outcomes. If you go into there, you'll find the things that I hope you learned at the end of Unit A. Unit B, you've got the Unit B learning outcomes, all the lectures for Unit B, the standard lecture content, and any additional activities or resources. Same thing with Unit C. So all the resources are out there on Canvas for those that need them. All right, so I'm going to stop share because I'm always nervous sharing my web browser, and especially when it's being recorded. So stop share. So are there any questions that I can field? Yep.
I just was curious if you knew, like, if on campus there's any like tutoring centers that like have been able to help with this course. I did try to go last night and they just said that they don't have tutors. So I wasn't sure if there's any like specific locations on campus that you've heard of.
Yeah, I actually don't know if so. You know, normally in the basement of what you call it Hull, that's next to Wrigley, there's a sustainability center that that staffs students that are available for that. That's I can send an email out if I think about it, but I don't know if they're currently staffing that this semester. The general math things, there is a math tutoring center that might be able to help. And they, I think, are pretty full featured, but I don't know if they limit their help to people in these math classes. So I will look into that to see if I can find another resource for you. But off the top of my head, the best place to go would be that the basement of, again, it's on the tip of my tongue what but it's the building that's like right next to Wrigley. And there's like a whole sustainability center like in the basement that's all staffed by students. I don't know if anybody, in Matthew Hall. Yeah, I think it's in the basement of Matthew Hall, Matthew Center. And so I believe that there, if you go down into Matthews Center, it's like back in the corner, this there's like little sustainability corner, and it's got like a bunch of cubicles, and it's kind of like a break room, and you sign in. And there usually, I think, are students there that can point you in the right direction. I think sometimes there are tutors there. So that would be the first place I would go and ask.
Thank you, that helps a lot.
Mm-hmm. All right, any other questions, specific questions or general questions? So I know that you know, the homework C6, it sounds like for some people it really forced you to kind of like to do those problems. I think there were a lot of students that identified deficiencies, but it also helps some students advance in some of their understanding of these things. So I'm happy to talk about homework C6, or if you want to go back, and if you didn't notice that there is a homework B5 solution set, if you'd like to discuss any of those. Again, for those of you who've already done the compliance check on Canvas, you can access the midterm module where there is a sample midterm. There is the exact same midterm that I gave in fall 2018 that I gave in the Scantron. So it wasn't Canvas based, but it was going to be a similar format. I think I gave that one as a Scantron. And so you could review that solution set and let me know if there's questions that you would like to go over on that.
I was wondering if you could tell us stuff that, I mean, like you, obviously everyone has like the different things they struggle with, but if you would recommend things that are like more of a key focus that we should either practice or just write on that like one sheet, just like things we should limit down that you'd say like apply the most, I guess.
I would say that on your formula sheet, so you get one sheet double-sided, and I would say on your formula sheet, I would recommend for most students probably to draw the negative externality graph as well as the public goods market graph, where you've got the supply and demand curves for both of those, and just to identify like where the deadweight loss is, where the lost producer surplus and consumer surplus is, those sorts of things. Because any problem I give you like that, I'm just going to be changing the numbers on a problem you've done before, because all the problems will have that exact same shape. But so once you solve for all the right intersection points, so like in the negative externalities problem, there are 4 points of intersection that if you solve for those, then you've got all the dimensions you need to calculate everything else. So long as you have that basic graph down there, then I think that'll be like a big help. Some other things that might be put down there is you know, if there are definitions that you get mixed up, like the difference between normative and positive economics, maybe that's a thing to put out there. There's a question about elasticity. So I would definitely put like the formula for PED, for the price elasticity of demand down there, and maybe an interpretation for that. Be able to solve for elasticity. I could give you a problem where I tell you how the quantity has changed given a change in price, or I could give you a demand curve, and I would ask you to calculate the PED from the demand curve. So, so both of those things are like, you know, quantitative things that we've definitely worked on. So there was a question, would I be able to go over inelastic versus elastic problems in the Unit B challenging problems? So so not know exactly which problems you mean about the Unit B problems, but do you mean specifically like, you know, which one of these things is elastic versus inelastic, or actually calculating the elasticity in the case of the question from Madeline? Or if you can point me to a particular, you know, assignment, which one is inelastic versus elastic? And so, like, if I were to, so like the lecture B5A. So if I were to reshare those, so maybe that's a good thing to start on. And then thanks for the other things queuing up in the chat. We'll work on those one by one. So if I open up lecture B5A, some demanding exercises, I am going to just go ahead and share. Come back here, Zoom. All right, so if I go and I think I had some sample problems to start with in this lecture here. So so there were these scenarios where I'd say like, well, if a good is a necessity, would you view it as being elastic or inelastic? And so if something is a necessity, I have to buy it. I depend on this thing, and I depend on this many units of the thing. I have to buy it. Does that sound like it's an inelastic or an elastic good? What do you guys think?
Inelastic.
Wouldn't it be elastic?
All right, I've seen one answer. Any other answers? All right, and then also let me then just remind you of the definitions here. So elastic means that when you apply a force, it changes. So this is an elastic ball because when I apply a force, it changes. Now, it happens to snap back. So there's like, it's a little bit of a mixed metaphor, like elastic versus plastic, but don't worry about that. Elastic is if I apply a force, it changes. So I'm saying that this ball is elastic, whereas this headphone case is not. If I apply a force, it doesn't change. Regardless of how much force I put on this headphone case, it changes, it stays the same shape. I put force on this ball and it changes its shape. The force in these economic problems is the change in price. And so the question is, how much, if I change the price, how much do I see a change in the quantity? So if a good is a necessity, if you have to buy a certain number of units, then we would expect that, and there's a couple of nice summaries here in the chat that I like here, we would expect it to be inelastic because regardless of what price I give you, it stays the same shape. You buy the same amount. So this is not elastic because I apply forces and it doesn't change. This is elastic. I apply forces and it changes. So in the case of a necessity, that, you know, I'm giving you the hint that I'm expecting the quantity to stay the same regardless of the price. If the quantity stays the same regardless of the price, it's inelastic. Same with habit forming. So if something is a habit form, or if you formed a habit, like a drug addiction, for example, or you know, I don't know, Netflix, something like that. If it is a habit that you are going to do it regardless of other cues like price, then that also is going to be inelastic. So the PED is going to be less than 1. What do we mean by the PED being less than 1? Remember, PED here, PED represents, I'm just changing my pointer, that that PED is effectively the delta Q over delta P. And so if it's less than 1, then that means that I get very little change in quantity, even though I got a big change in price. That's what I mean by less than 1. And I'll put absolute value signs around this because technically negative and positive matters, but they're almost always negative. So we just usually refer to them in terms of absolute value. So if something is habit forming, then that means that I am going to keep doing it regardless of what the price is. I apply a force, and it's like this iPhone case. I apply a force and it doesn't change. If it's trendy, that's also another one. I'm just giving a bunch of, oh, and so there's a question, and if it equals 1. So if the PED equals 1, we might refer to that as, marginally elastic. I'm not going to ask you questions that are about that kind of like edge case, but if the PED equals 1, then that just means that if you double the price, you have the quantity. So you end up getting did I say that right? It means a meaning that the delta Q over the delta P. So I guess I should have said it's the relative. So this is delta Q over Q and delta P over P. And so the idea here is that if you change the price and you get the exact same scale of change in quantity, then it's sort of marginally elastic. That's the PED equal to 1. But I'm really only focused in this class on like the extreme cases. And so all of these cases that I've given you right here are all inelastic cases. So trendy and in fashion, that's an inelastic case. The case of an elastic case, which for some reason I didn't have one in this slides, or maybe I did, but oh, I see, but it was just in my little preview, it's not showing here. This is the case of an elastic. So this one here, when there are substitute goods available, then that means that when you apply a force of a price, people change their behavior. They stop buying the high-priced goods and they start buying a substitute. So if substitute goods are available, it's elastic. So you get a major change in quantity for a small change in price. So that's an example of an elastic. So does that help? The elastic, like this, I apply a force, I apply a price, and I get a change in quantity. Elastic means PED is greater than 1. Inelastic, it's more like this. I apply a force and nothing changes. So in the inelastic case, it's almost like the delta Q is equal to 0. And in the elastic case, it's like the delta Q is equal to infinity. Okay, great. So let's see what it's there. I had some other questions queuing up there. A PED calculation example, sure. So I will then flip maybe to the virtual whiteboard here. Sure. Okay, so I thought it was sharing. Oh yeah, I think yeah, good it is. But my PowerPoint is taking up my screen. All right, sorry about that. There's a question that said a PED, so there's 2 types of calculating PED. And so so if you remember, the PED formula is going to be delta Q over Q divided by delta P over P. And that is in the case of, if I gave you curves, then it's the slope, it's kind of the inverse slope of the demand curve times P over Q. And so we'll get to that in a second. So those are the 2 forms, and I would probably have both of those on my formula sheet. And then I might say that I have a certain change. So let's say that ASU implements a tax on coffee. And so due to that tax on coffee, we see causes a 10% increase in price. And that 10% increase in price, then if we look at sales data, leads to, let's say, a 20% reduction in coffee sold. So in that case, because I've already given you the percentages, I've already given you the delta Q over Q. The over Q is already taken and the over P is already taken. So that tells me that delta P over P is equal to 10%. And it tells me that delta Q over Q is equal to, technically, it's equal to negative 20%. And so with this, I can calculate the PED to be equal to negative 20% over 10%, which is equal to 2, or negative 2. And so the absolute value of the PED, which is normally what we care about, is equal to 2. And so that means that, well, so what is this? Is this an elastic or an inelastic good? Anybody in the chat? So you can say, is this elastic or inelastic? And I'm seeing a bunch of elastics, and that's right, it is an elastic good. So I'll circle elastic and I'll cross out the inelastic. And that's because this thing is greater than 1. So it's greater than 1. So that there is the calculation. And we interpret that to say that we are going to get double the impact of a price change. And so if you change my prices by 10%, you're going to change my quantity sold by double that. So by 10% price change gives me a 20% quantity change. So that's kind of how we interpret that. So that is one way that I could ask you to do that. Now I could also ask you to say, I could say that, well, I could do in absolute quantities. I could say that the price increased from, let's say, $2 to $2.50, and the quantity decreased from, well, you know, ideally I would, you know, it could be 10 million or something like that, but just to make the numbers easy to write down on a piece of paper, I'm going to say the quantity sold, these are like cups of lemonade per day or something like that, then sold decreased from 10 to 5. So now I need to say, okay, well, my delta P is going to be 50 cents. So that is 50 cents. But my P that I was is equal to $2. So that tells me that the delta P over P is equal to 50 cents divided by $2. And so 0.5 divided by 2 is 0.25. And then my delta Q is negative 5 units, like 5 cups of lemonade per day. And the Q that is relative to is the original Q10. So that means that my delta Q over Q is going to be negative 5 over 10, which is a 50% reduction. So this 25, by the way, I could view as 25%. And this I could view as negative 0.5 or negative 50%. So if it's easier, you can just say, don't worry about the percents and just keep them in these units here, the non-percentage units, just so you know, that way you don't run into the problem of accidentally calculating one in percent and the other one not. So now to calculate my PED for this case, It's just the change delta Q over Q divided by delta P over P. And I know my delta Q over Q is negative 0.5 or negative 50%. My delta P over P is 0.25. And so that right there, if you divide 0.5 by 0.25, then hopefully that should make sense that that's also going to be negative 2. So that PED, and I could also say the absolute value here is equal to 2. So it just happened to be that in the lack of creativity in my mind, I managed to calculate the exact same PED as the previous one. And that suggests that this lemonade or whatever I'm talking about is elastic as well. And it happens to be the same, but that was just a coincidence. There's nothing special about 2. All right, so those are the two types of examples without using demand curves. And then the last one is to use demand curves. So are there any questions on that before I move to the demand curve PED example? No, all right. Okay, so let's do, I'm gonna switch to a new page. And I'm just gonna again put our PED formula up here. And that PED formula, delta Q over delta P times P over Q. And so if I were to draw say a demand curve like this one, this is in quantity, and this is in, basically price, dollars per quantity. And so most of our demand curves are going to be linear. If they weren't linear, if I do give you one of these things, it'll be linear on the midterm. If this wasn't linear, so on this, I would give you like a demand curve. So I could give you something like a line that maybe, like let's say I say that the demand or the marginal benefit is equal to 1, 2, 3, 4, well, I'll say 3 minus deciding on a slope here, 3 minus 1.5 Q. And so that tells me that I would plot this thing up here. This is 1, 2, 3. So I'll start plotting it here. And then rise over run is 1.5. And so I'm going to then go over, every time I go over 1, I'll go down 1.5. So that means that it's going to hit down here. So I go over 1, down 1.5, that puts me here. Over 1, down 1.5, that puts me there. So my demand curve looks like this. And if I were to, well, I'll just keep it simple for now. And then I can say that, let's just say we are at a price of $2. And the question is, what is the PED at this price? And so, and by the way, if in the chat there is an advertisement for a study session that is organized by another student in the class. So Ariana has offered, if you're interested, I think that's a great thing to do, is to join together for these sort of study sessions. So, and anything I can do to help facilitate that, again, we have a Slack page that you're welcome to use. There's the discussion groups. Feel free to, to post things on the discussion groups if you want to advertise, like if you want to organize study groups, but you want to get people aware of your organizing study groups, feel free to use the resources that are on Canvas to do that as well. Happy for that. All right, so so at this price of $2, then we need to figure out what is the quantity here. And so for this problem, that's this function here, I'm going to need to invert. So I know that I've got P is equal to 3 minus 1.5 Q. So that tells me that P minus 3 is equal to negative 1.5 Q, which tells me that 1.5 Q is equal to 3 minus P, and Q is equal to 3 divided by 1/2 minus P divided by 1, not 1/2, 1.5. And so I'll just simplify that to be 2 minus 1 over 1.5 times P. And so that tells me that if I were to plug in this price of $2, then the quantity I get out is 2 minus 2 divided by 1.5, which, if I do the math, 2 minus 2 divided by 1.5 is 2/3, 0.67. And so this down here is 0.67, or 2/3, and that's the quantity that corresponds to this price. So P equals that, and Q is equal to that. And so so that gives me these two, P and Q. All that's left is this. And so that there, if this demand function is a line, so in the line case, then partial Q over partial P is just equal to delta Q over delta P, which is kind of like run over rise. And so I can see here that I know that down here, this thing intersects at 2. So I can see that the total run is equal to 2, and the total rise is equal to 3. So if I put this down here, is that for a run of 2, I get a rise of 3, then that tells me that my delta Q over delta P is equal to 0.67, which just happens to be the same number that I calculated, but that's a total coincidence. So my PED, and I guess I technically should make that negative, because as the price increases, then I get this negative change in the quantity. So my PED then is going to be the negative 0.67 times the price, which I gave you as 2, and the quantity, which is 0.67. And total coincidence, it comes out to be -2 again. So the absolute value of the PED is equal to 2. So at this region here, this is elastic, and it has a PED of -2. Now there's a bunch of variations on that. I could give you the curve and not the formula. So you would then have to figure out the formula or solve graphically for these price and quantity. I could have given you the quantity and said, what is the elasticity given that this is the quantity available in the market, and so on and so forth. But, and I promise that these don't always end up being 2. That was just bad luck in my crafting of these problems, that they happen to all come out to be 2 in these examples. So are there questions about that? The 3 different ways you could calculate PED. Okay, so as you think about that, I'm going to look through.
I'm sorry.
What was see if there's other questions here.
Oh no.
PED calculation, is it possible to release the solution set? There's a question, is it possible to release the solution set for between homeworks for homework C6? It should be released. I can double check on that right now, but it was scheduled to be released today at 10:15 a.m. So that was part of the, so if I go to the solution set here for homework C6, it tells me that it is available at October 20th today at 10:15 a.m. So you should have access to that solution set. If you don't, let me know immediately, and I will see why Canvas isn't giving you access to it. But that solution set should already be available. If you can't find it, go to Modules in Canvas, and then go to Unit C, and then you'll find it under the homework in Unit C. There's a homework C6 solution set.
I got a question.
Sure.
Well, what was the first way that you showed it, like for calculating PED. So this is the graph version. What was the other version according to the formula itself again?
So the other versions over here where I can give you percentages like I did
Percentages, got it.
up here, or I can give you the raw numbers and you have to calculate the percentages yourself.
Oh, okay. All right, just making sure.
Mm-hmm.
And this where can this review session can be like, where can you find a recording of it?
It's in the same place as all the other recordings. So if you go to Canvas and then go to module, or if you just go to the Canvas homepage, right there on that main homepage, in the middle of the homepage, there's a bullet that says, and I can read it, or I can maybe share a small portion of the screen. So share screen, advanced portion. So right, I'll highlight. So in the main,
Oh, okay, I
right,
see it.
yeah, you see right there in the middle, it's
Yeah.
captured. That's one place to get to it. The other place to get to it is if we were to go up here and click on modules here, then there's a couple of different ways to find it. If you scroll down in Canvas, then there's this classroom recordings module, and you can click on captured classroom recordings. If you go into there, those are all of our lectures throughout the entire semester, and I will add this one right after this one down here.
Okay.
And the whiteboard PDF, I'll put links right here.
Okay. And another question regarding the exam itself, when it comes to formatting or like answering the questions, is it all gonna be purely multiple choice, or is it gonna be also including questions like select all that's following with this question or something like that?
It will, I mean, it's going to be a Canvas-based exam, and so it'll be the Canvas type of questions. And so multiple choice, there's probably going to be a lot of those. There might be a few where I ask you to select multiple.
Yeah.
That I think is fair game. There might be a few where I ask you to calculate a number, and the expected answer will be that number within a range, because you can do numerical calculations on Canvas. There might be a few matching problems, so I might have a couple of goods like necessity, substitute options, etc. And then you have to match them to whether they're elastic or inelastic. These are all sort of types. Like I said, there is a sample midterm available on Canvas that was a Scantron midterm, but I use in Scantron the multiples and things like that as well. So that would be a good idea of where to start with what types of questions I might ask.
Okay. And someone's asking in a chat that's saying, will there be a curve to the midterm?
Well, I don't know how, because midterms you don't get a letter grade until the end of the semester, and you get a letter grade for the whole class. And so the grading policy for how we assign letter grades is mentioned in the syllabus, where I've set out kind of a minimum grade that you're going to get, and then there might be some minor rounding up at the end, depending on the distribution of scores. But like you just get a numerical score for the grade. And so there's not a curve. Of course, if I make a mistake on a question, so like if I give you a multiple choice question where the answer is not in the multiple choice, everybody's going to get credit for that. But I don't like, there's no handicap that's being built in where like everybody gets like a 5 points. I could have a bonus question on there that might give you a little bit extra or something like that. That sort of thing is possible. Canvas limits a little bit of what I can do for that, but I don't quite know what a curve would look like, because that would be like a numerical adjustment of numerical grades. And I'd like to do all of that at the end of the class after everything has been tabulated together.
And we will get a result immediately, like after the exam, right?
I think Canvas will give you your numerical score immediately, I'm pretty sure. And then I've got it configured so that the day after, you'll be able to review your individual question scores.
Okay.
And then the midterm solution set will be available the day after, again, at like 10:15 a.m. So the Friday after you go to the midterm, you should be able to click on the solution set and it'll be available, and you'll be able to review all of that.
Okay.
There's a question about formatting the exam. I hope I sort of answered that. I actually still have to write the rest of the exam. So, but the idea is even though I give you 90 minutes, the design of the midterm would be for the average person to finish it in an hour. So some of you will finish it a lot sooner than that, and the rest of you will have a lot more than that. It's not my goal to get you to use all 75 minutes. I give you 90 minutes again, but it's not my goal to get to use all 75 minutes. It's my goal to assess the learning outcomes. And so I come up with roughly an hour's worth of questions, and that are going to be arranged usually in order by unit. So I'll answer Unit A questions and Unit B questions and Unit C questions. And then they generally, I'm going to make the questions kind of get harder, whatever that means. There's going to be conceptual questions in the earlier units that might be pretty hard. So, but I still try to make things kind of more numerical towards the end, more conceptual towards the beginning. So that's how I shape that. And then there is, there was that. Thanks for answering that in the chat. You get 2 initially blank sheets of scratch paper. And so you'll be able to show those to the camera and then work on those during the exam. Let me see if I missed anything else. A really hard time identifying characteristics of social welfare functions. Can we review that? And then it looks like there was a second for that. So yeah, I think that's actually an excellent idea. So let's flip to, I guess what I can do is, we'll do this by hand, at least initially here. So let me flip back, or we'll do a mixture of things here. Okay. All right, so for these social welfare ones, I will point out that if you go back to the Cardinal Social Welfare lecture, I've added a couple of additional notes to some of these pages just based on questions that I've received throughout the semester. And so if you go back and review the lecture 4 notes that I've posted on Canvas under the standard Unit C. So these aren't the ones I hand wrote. These aren't the whiteboard notes that are in the captured section. These are the main lecture notes under the Unit C. And I've tried to add some additional notes to help sort of understanding, like, what does it mean to be convex and those sorts of things. So I'll leave that up here just in case I need to go back and refer to that. But the main social welfare functions that we talked about were the benthamite, in which the special cases are strict utilitarian. And then we said that the social welfare for benthamite is going to be if I've got the utility of person A, there's going to be some, I'll use lowercase letters, how about that? So I've got person A has got utility A, and we are going to weight how much we care about that person by lowercase a. Person B has got utility B, and we are going to weight how much we care about that person with lowercase b. And that goes up to, person Z. There can be a whole bunch of people, and we can weight them so that somebody gets more importance than others. And so in the special case where A is equal to B is equal to C is equal to all the way up is equal to 1, that is the so-called strict utilitarian, where it's just UA plus UB plus all the way up through UC. And that's just maximizing total utility over a society. And if I were to plot the indifference curves for a benthamite, the key feature in the benthamite is lines. And so I'm going to have parallel lines whose slope relates to these coefficients that are out front. And so a generic benthamite social welfare function will look like this. And so this here, this social welfare function is one where so these are the indifference curves. So the indiff curves are lines. And these, the way it's drawn right now, so if I do UA up here and UB down here, then what we're saying is that if person B has got very little utility but has some, and person A has no utility, that is, to us, that's the same social welfare as person B having no utility and person A having a lot of utility. So this, the generic Benthamite social utility function does not meet the equal respect condition. So if we were to draw a diagonal up through here, then you can see that generically you cannot fold this. If you were to take this curve and fold it over the diagonal, you do not get the same curves back. So we treat person B differently than we treat person A. So so for the same social welfare, so if this social welfare was equal to 5, then that might mean that 5 is equal to 5 units of pure person A, or that might be equal to 3 units of pure person B. So person B here, if person B were to increase to 5 units, then that's going to be better for us than person A increasing to 5 units. That's kind of what we're saying here, is that for 5 units of social welfare, that's worth 5 units of person A's happiness, but only 3 units of person B's happiness. And so increasing social welfare, you're going to get a different contribution from these different individuals. So if these became totally vertical, then that would imply that our social welfare was totally determined by person B and not by person A at all. So as they get more and more slanted, we are favoring one person over another. And so in general, this is not equal respect. It does not have the equal respect condition. In the special case of total utilitarian, so that's when all of the coefficients are equal. So in the strict utilitarian, or the total utility, this one does have the equal respect condition. So this is a special case that has equal respect.
So
And,
Bentham, oh,
go ahead.
I was gonna say, so Benthamite, it doesn't have, how do you say it, equal respect condition, doesn't meet it, but the strict utilitarian does.
That's right. The general Benthamite doesn't. But in the special case where all the coefficients are equal, then we're saying that we care equally about every single person in the social welfare calculation. So in that special case, then the strict utilitarian does have it. And so if I were to draw that special case, then the strict utilitarian is going to be lines, but they are going to be diagonal lines at a 45-degree angle. So
Okay.
they'll be like this.
Okay, I was just gonna say, well, there goes my homework question.
Yeah, so if these are at 45-degree angle, then this is the special case, special Benthamite, that has equal respect. Now, one thing that neither one of them has is neither has the inequality aversion. There is no benefit if you hold the total utility constant, but you change the distribution of wealth to make it more equal. You don't get any benefit in any Benthamite utility function. So the other utility functions then add that in. So if I go to the Rawlsian, then it's the minimum of all of my utilities. And so as an example, like if I had utility A was 10 and utility B was 30, then this thing is equal to 10. I just pick the minimum. And so this one, the Rawlsian looks like these corners. And so the Rawlsian here has both equal respect and inequality aversion. So it's equal respect because if I went up through the diagonal here, then I can see that if you fold it, you get the exact same utility function out. In other words, if you swap the position of two individuals in society, it does not change the calculation. Min of 10, 30 is equal to min of 30, 10. And that right there is equal respect. Now, it does have the feature of inequality aversion. So it has inequality aversion. And that's because these lines here bend in toward the origin. So what we're saying here is that if you had the same total utility, so let's just say if I were to draw a total utility, so if I'm just going to superimpose, so this right here is a total utility indifference curve. Then what this is saying here is that this total utility indifference curve intersects the Rawlsian indifference curve at these 2 points. But every point between the two intersections is left of, well, I guess let me say that another way. Every point of the total utility function that is in between these two intersections is actually at a higher Rawlsian social welfare. So if I hold my total utility constant, so let's say I'm up here, if I'm at a very unequal, if I start in this position up here, then I'm saying that one individual, so that's maybe, individual A. So up here, I'm saying that individual A has gotten more than individual B. So we are not an equal an equal allocation in society. If I add to individual B by taking away from individual A, I stay on the same total utility, but I move into this middle region here. And this middle region here is going to necessarily be on a higher Rawlsian indifference curve. And so if I were to label these indifference curves, I could say maybe this is I3, this is I2, this is I1, and I3 is greater than I2 is greater than I1. And so moving from this point to this point, even though the total utility stays the same, the Rawlsian utility goes up. And that's why Rawlsian utility has inequality aversion. It promotes more equal distributions of wealth. So Rawlsian has got both features, inequality aversion and equal respect. Then we talked about egalitarian is the mixture of those two. And the egalitarian utility function is just equal to the total utility. So UA plus UB plus all these things through, plus some parameter that you, the analyst, sets. And then that gets multiplied by UA minus the minimum plus UB minus the minimum plus, and this goes on until UZ minus the minimum. And then this here is a parameter. And that parameter lets you turn an egalitarian anywhere you want from a total utility all the way to a Rawlsian. So when lambda is equal to 0, then you get total utility. When lambda is equal to 1, then you get Rawlsian. So the total utility is just the sum, and the Rawlsian is just the min. And so the graphs for these in general look like a mixture of those two. where they do have equal respect. And for most cases, they also have, so these are meant to be symmetric. So this is supposed to be symmetric along diagonal. And it's got both equal respect, and as long as lambda is greater than 0, it has inequality aversion. And so that inequality, so this egalitarian gives an analyst a tool to be able to penalize these unequal distributions of wealth. And then the last function that we had here was the Cobb-Douglas, which is an alternative way that you can do that, where it is just equal to the product of all of them. And so the shape those are going to look like these curves. And the Cobb-Douglas has both the inequality aversion, because it's convex down, it's bent in, just like the Rawlsian, and it also has equal respect, because it's symmetric along the diagonal. In other words, if you swap UA and UB, it doesn't change the social welfare. And so those are kind of those shapes there. All right, so those are the shapes. Do those shapes make sense? Are there questions about any of the shapes, the social welfare shapes and the functions that go into it?
I had a really hard time graphing the Cobb-Douglas. Like, I just didn't know how to graph it accurately. I don't know if you just covered, I was just taking notes, but I would love if you would show a little bit of that, how to graph it accurately.
Sure. I mean, on your homeworks, I'm okay with just a hand sketch, but to graph Cobb-Douglas indifference curves accurately, basically what you do is you say, well, okay, this indifference curve, let's say this indifference curve has a social welfare of 3. Well, what we're saying there is all along that curve, UA times UB is equal to 3. Well, ideally, I'd like to turn this into something that I'm used to graphing, which has a y-axis and an x-axis. Well, UA kind of takes the role of the y-axis, and UB, in this case, takes the role of the x-axis. And so if I view this not as UA times UB, but I view it as x times y is equal to 3, then that would tell me that this curve that I draft here would be just equal to y is equal to 3 divided by x. And so that's basically each one of these curves is going to be equal to UA is equal to whatever the social welfare is of that curve divided by whatever the UB value is. And so using this formula, you can put in different social welfares, and that will give you different curves. Does that make sense?
Yes, that does. Thank you so much.
Okay. All right, so I saw several other questions. There was a question about whether I can have additional office hours this week before Thursday. My Wednesday is always pretty packed. I'll see if I can free up something Wednesday evening, but I don't have any guarantees. I don't know if Moksha is on, but if she is, she may have some availability, and you can also contact her about that. I'll see what I can do. Other questions? MRS and discount rates. So yeah, there are questions. So I'll handle that one next. So marginal rate of substitution with the future. So with the future. So the marginal rate of substitution with the future is just this formula. 1 plus the discount rate to the time, where so R is the discount rate. And then T is kind of this compounding period. So that's T and that's R. And so what I hope you can see here is as R increases, the MRS decreases, and vice versa. So so if I were to, I can solve this thing. So let's say for the t equals 1 case, which will be the case we normally consider in this class, then I can say that MRS is equal to 1 over 1 plus R, which implies that you can just solve for R in terms of MRS. And so if I do that, then the first step of that is to say, okay, 1 plus R is equal to 1 divided by MRS. And so I can divide both sides by MRS and multiply them both by 1 plus R. And then that tells me then that R is equal to 1 over MRS minus 1, which if you prefer, and you don't have to write it this way, you can say it's a 1 minus MRS divided by MRS. But this form right here is probably fine. And so I think you can see here that as MRS increases, then the discount rate decreases. And so that's the relationship between the two of them. So in any one of these, I could give you the MRS with the future. I can say future rewards. There's this, and sometimes we refer to this MRS with the future as the F over, I'm sorry, the MRS with the future is what we multiply the future rewards by to get the present rewards. So sometimes this is referred to as a P over F or P over F. And so if I give you future rewards, I multiply them by this to give me my present value. And so, so if I could give you that MRS and ask you for the discount rate, I could give you the discount rate and ask you for the MRS. The way you would use this is I might say that you're going to be given $100 next year. What is the present value of that in today's dollars? And I would give you a discount rate. And then you know to divide $100 by 1 plus R, where R would be that discount rate. So does that clear up these questions about MRS and discount rate? Are there other questions about that? The discount rate is also equal to the interest rate. Those are identical terms. So any questions about that? I see some questions about the deadweight loss, etc. Those are more involved, and I'm happy to do that, but I just want to make sure that if there's specific questions about MRS and discounts, I don't skip them. Okay. All right, so about the calculations for, so I mentioned that some of you may have seen it already, there are these additional units that, so down here I've got them, the notes from them. So there are these 4 videos that I created, and the negative externalities and the positive externalities of public goods are the ones that, those are the videos that are just a refresher that can allow you to go through an example problem that I've done there. And I'm happy to do an example problem here, but this is the type of graph that, having this graph handy on your formula sheet is probably useful, because every single problem that we do with a negative externality is going to have the same things. It's going to have a demand, it's going to have a PMC, it's going to have a marginal damages. You'll combine the PMC and the marginal damages to create a societal marginal cost, and you'll plot all those things: societal marginal cost, demand, private marginal cost. And with those 3 lines right there, then those 3 lines there, you can end up solving all of these problems, because you just solve for this triangle and this triangle. And so these 4 points right here, so I'll wait for that to describe these 4 points. As long as you have those 4 points, you can solve all of these problems. And so I can change the numbers, but in the end, all of the formulas you use, if you knew all of those formulas based on these 4 points, you could solve all of these problems. So this is one that I definitely would recommend having. And then the other one I would definitely recommend having is that public goods case. And so this is a much simpler looking graph, but any kind of market problem with public goods is going to look very similar to this, where I'm going to have a demand function for my contributors. I'm going to demand function for my freeloaders. You're going to use the supply function with the contributor demand function to find the market equilibrium, and then you're going to combine the two market or marginal benefit functions to find the societal marginal benefit, and then use that to solve for where things should be if everyone was paying in. So with these three curves and the supply curve, you can then generate these 3 points, which allow you to solve for everything I'd possibly ask you about. So I would have this graph and those graphs available so that you know what curves you're looking for. All right.
Could I ask something
Yep.
like more specific
Sure.
related to that? So I know like regarding my questions on the homework, you sent me the first one and it was really helpful, but I was wondering if you could do almost like the same graph, but making the P and the Q different numbers, just because the way the equations were, they were both 4.5. So I got really confused in calculating it since the numbers on the homework were different. Like each one of like which number first or which subtracting what is which. If you could like, just because I calculated the lost consumer and producer surplus correctly, but then since like they were using the same numbers in different order, I guess I like did that for deadweight loss. So like my calculation for that is the answer under that. So I guess like if there's just, I don't know, a better way to like differentiate them.
Sure. I mean, that was sort of probably just a coincidence that I happened to choose one that it just happened to come out that way. I could probably come up with one quickly here where they won't come out that way, and I'll try to work through the problem quickly so that because I know we only have a few minutes left.
Sorry. Or even if you don't do the whole thing, but like if you can write the equations without the new numbers in them, like what that value would be, if that makes sense.
Yeah, I think so. Let me see. Like, I'll try to create something here that, so like if I had a marginal benefit that was like 3 minus 0.5Q, that's going to be a pretty flat marginal benefit curve. So I think it'll be, here's 3, 2, 1. 0.5Q means that every 1, 2, 3, 4, 5, 6. So now every 1 I go over, I only go down half. So every 2 I go down over, I go down 1. So I get this. So I would get a very shallow line. And then I could give you a Q or a marginal damage. If I give you a PMC equal to, say, I give you a PMC equal to 0.5Q and a marginal damage equal to 1Q, or I'll do a marginal damage equal to Q, then my societal marginal cost will be equal to 1.5Q. And so that means that my societal marginal damage, every 1 I go over, I go up 1.5, up 1.5. So I end up getting this curve right here. And the other thing, the important thing that I need to graph then is the PMC. And so with the PMC, starts from down here, and I go over 1, over 2 and up 1, over 2 and up 1. So that PMC is going to look like this. All right, and so this PMC is the supply, and it looks like for this particular one, I should have drawn my societal marginal damage higher. So it would go up to like here. And so with this, in order for me to solve for this point, I would set my PMC equal to my marginal benefit. So that's 0.5Q would be equal to 3 minus 0.5Q. So that's Q is then going to be equal to 3. And so that's what I got down here. And if I evaluate the, so that'll be equal to 3 comma 1.5, because this is 1.5. And so that 3 is equal to Q market, and that 1.5 is equal to price market. If I go all the way up to this point to solve for this point here, then that is my societal marginal cost, which is 1.5 Q. Well, so that's going to be that at a quantity of 3, I'll have a societal marginal cost of 4.5. So that's just the SMC evaluated at the market of 3. So that's how much cost that I'm adding due to the extra pollution, due to that marginal damage. And then I need to know the market equilibrium, which is just setting societal marginal cost equal to marginal benefit, which is 1.5 Q is equal to 3 minus 0.5 Q, which should be 2Q is equal to 3, and Q is equal to 1.5. So that's the 1.5 here, which is equal to my Q star, my efficient quantity. And then the price that corresponds to that is just going to be equal to my 1.5 Q societal marginal cost times 1.5, which is 2.25. And that right there is the price. And so that point inside there is 1.5 comma 2.25. And then finally, the only point I need to worry about here is this point down here, which is just 1.5 is the quantity, and it's just my private marginal cost, which is half of that, which would be 0.75. So that right there is the private marginal cost at the efficient equilibrium. And so if I wanted to calculate deadweight loss for this problem, that is just going to be equal to 1/2 times the height here, which is 3 minus 1.5. So that right there is QM minus Q star. And that's the height of this deadweight loss triangle. I call this height. And then this is the base. And that base is just going to be the difference in the y-axis. So that'll be 4.5 minus 1.5. And I apologize, I didn't, just the luck of the numbers that I got two 1.5s here. This 1.5 is a quantity, this 1.5 is a price, and it's just bad luck. But this right here, if I were to work that out, that would give me the area of this thing. So I'm not going to worry about working that out right now, but that is, this whole region here is the deadweight loss. And the lost producer and consumer surplus at the efficient equilibrium is inside here. And so that lost PSCS is 1/2 times actually the same height, 3 minus 1.5, but now it has a different base of the triangle, where the y-axis here starts at 2.5 and then it ends down here at 0.75. So I said 2.25 minus 0.75. And so I just make it clear that this is 0.75 there. And so you can then calculate that. And so if I won't do the rest of the calculations, but those are the two kind of major areas. And then the other things I might ask you about are surplus. And so I would probably ask you that for the market price at the efficient equilibrium, which is here, then we know that the consumer surplus is everything above that, and the producer surplus is everything below. I should put that in a different color. So maybe I'll just highlight the producer surplus is everything below that in this trapezoid. So
Sorry,
that right
do
there.
you mind, like, for this equation 2, writing out what like the producer surplus one look like? Just because with the last one, like I also got that wrong because I think those were the same. So, like, how do you know which base? You know, like how it'd be like the base plus the base or the height. Or I remember in the example I looked at, you were subtracting one of them. So I guess like what would determine you subtracting something from something for like one of the base numbers?
So there's two ways if you get one of these trapezoids, and so if you've drawn the trapezoid out like so, then I refer to this as the height, and this we'll call base 1, and this called base 2. So this base 2 goes the whole length, and this base 1 goes the short length, and this height goes just this width here. And the area of a trapezoid is equal to 1/2 times the height times the sum of the two bases. The alternative way to view that is you can break this into a rectangle and a triangle. And so if I were to draw a dotted line, maybe, then this rectangle here up top has got an area equal to height times base 1. And this triangle that's down here, well, so this is the height, and this is the base 1. This height of the triangle is equal to base 2 minus base 1. And this is still equal to just h. And so the area inside here is just 1/2 base 2 minus base 1 times h. And if you add up this formula plus this formula, you will get this formula. So the minus that you might see probably came from solving for this tiny height here, which is equal to this one here, which is just the difference between these two. But given that you know that trapezoids are frequently solved for, if you just remember this formula up here, you don't need to break it apart into a triangle and a rectangle. You can just say, well, I'm going to add up this base plus this base times this height, and that whole thing times 1/2. And that gives me the entire area of the trapezoid.
Perfect.
And we're
That
at
was
120
great.
right now.
Okay,
So
sorry.
no
like
problem.
just on the last thing that you went away from, so like the dead weight loss, you know how you said you ended up with two 1.5s. So would it be QM take away like the quantity at equilibrium, and then the price M take away the price at equilibrium? Is that how it works? Or
Well, hold on one second. Let me make sure that, so I do want to give people credit for attending today. So the attendance question, I put the link in the chat, and I'm just going to make an easy question as to what day is this week's midterm. So that's your attendance question. Easy question. What day this week is the midterm? And so I'm sorry, then can you ask that, can you say that question one more time that you had? And then and everyone else, if you know, that's all I've got for you. So you can feel free to hop off, or you can stay on. I'll stick on for a couple more minutes if there's a couple more questions. And I'll keep this recorded as well for anybody who needs to pop off and wants to listen to those questions. Go ahead.
Okay, so do you like still have access to that image? I have a screenshot too if like you need it.
Yeah, I have the thing that I was
Yeah.
Which one you mean, like
The
this
thing
one?
before the trapezoid, no.
Okay, the trapezoid one. So here or over here?
Right before, yeah. So C for dead weight loss, the second part where it's the 4.5 takeaway 1.5, said something about how which 1.5s which one are, I guess. But I didn't quite catch that. So is the second part PM takeaway P at equilibrium, or?
This second part is is this 4.5 up here. And so I guess I could draw that this 4.5 right here. And this 1.5 is this 1.5 PM down here. So right there. So that is PM. And this doesn't have a name, but you can just think of it as the social marginal cost at the market equilibrium.
Okay, perfect. Thank you so much.
Mm-hmm. All right, any other burning questions that people would like to ask before we end the meeting?
No, thank you so much.
Good luck, everybody.
Thank you. Have a good day.
You too.